Hello, welcome to the updated Editable Mesh tutorial. Today we're going to review what has changed and what limitations did they add. First, you are not able to create Editable Mesh unless you enable it. So if I'm going to try to enable it, you get in this weird square and it's going to tell to go to the security tab in game settings and enable this API. Let's do it right now. So we're going to File, Game Settings. If you're using the older UI, it's probably a little bit in a different place, but you should probably recognize this menu. And what we are looking for is this checkmark, Allow Mesh and Editable Image APIs. For now, you see the text, this experience can access Editable Mesh and Editable Image API. But for people who don't have their IDs verified, this text is going to be different. I will try to show that in a screenshot right now. It's going to tell us that it requires ID verified and 13+ account. So that's quite a big restriction because most of the users, I believe, don't have their ID verified because they just don't want to upload their document to the Roblox. Anyway, let's save it and let's continue. We're going to experiment on this guy. So he has already the script that creates the editable mesh for him. We're going to review that script in a second. So you see, it's working, nothing on output. That is mesh uploaded by me. That means I have the ownership of that model. But if you're going to try to edit somebody else's model, let's say like this hair I found in Toolbox, let's put the script in this hair. And you get a warning and an error that this asset is owned by different user and you have no permission to load the asset. That's quite a big restriction as well, that you're not able to use anybody else's mesh, only yours. Probably there's settings to configure the permissions of it that anybody else can use, but I haven't found it yet. Let's go back to our guy and delete this hair. So let's see how we can create the editable mesh now. I prepared the script, so let's take a look. First, we're starting with asset service, and then already something has changed. Let's look at the methods that allow us to create the editable mesh. Just create editable mesh, async, and create editable mesh. Create editable mesh async allows us to create editable mesh from the mesh part, so from the existing one, like this guy. And we're having just create editable mesh, which is going to create an empty editable mesh. We're going back to that a little bit later. And now let's see how we can create from the existing one. First, we see that mesh part has a new property called mesh content, which is just content, and as well they added the new instance called content. So first we have to create editable mesh. From the part we're using script parent mesh content. Again, the script is in the mesh part, and then a little bit weird part, but we have to deal with it. We have to create additional mesh part. So we're doing create mesh part async. So we created editable mesh and now we're creating editable mesh part. And we're passing content from object. And since they added new instance like content and object, we have to pass the editable mesh. As far as I understood, editable mesh now creates like a copy of the mesh in the memory that we can edit and apply changes to it. And we're still having like the original mesh that we can just always go to it and look how it looked like. And probably something with memory allocation and other stuff. So let's look. After we created the mesh part, instead of parenting it directly, we could just as well parent it. It's no problem. If we want to change the original mesh, we have to take that created mesh part and we have to apply mesh. And now, every change we're going to do to editable mesh is going to reflect on the original mesh part, and we don't have to apply it each time. It does automatically because editable mesh already copied the whole mesh, like ID, to another memory. And now by telling apply mesh, we're saying that this mesh part have to go to the memory and look at the mesh part that is created by Editable Mesh. So let's take a look at what changed and what has been added. First, you already see that they added a strange method called triangulate. You're probably gonna tell that it's redundant. The same thing I told, because the Roblox already triangulates everything when you upload it. And now we have that strange method triangulate. But let's open the documentation for it. They mention that even in the documentation that it currently does nothing. That means we all the time having the triangles. But probably in the future, we're going to have like quads and other types of polygons. But that's not now. And let's see what they have added here. We already see some changes. Like they added colors, UVs and normals. So like they separated everything. And instead of colors, UVs and normals directly bound to vertices, which increases the memory usage, right? They decided to separate it into IDs. For now, it tells that everything is an array of any, but everything is the number array. They just haven't changed it yet in the documentation. So now we can have like one normal ID, for example, and assign that normal ID to a couple of vertices. That reduces the memory usage and probably even the computational usage. So let's continue and let's try to do something with Editable Mesh. I prepared already a couple functions and let's look what they do. First, we're going to have the scale, like in the previous videos where I showed where it like wrapped the ball, just got very scaled, very small, and so on. That is literally the function, just to set the position of the vertex. So what we're doing here, we get in the position of the vertex, and we're multiplying each vertex position by scale, and we setting the position back to that vertex. So let's look how it's going to be. You see, our character became like twice as small, and it's in fact not anchored right now. And if I'm going to rotate, it's going to fall. And as you see, it has physics of the original mesh. That means like, even though it's small visually, physics-wise, it's still big. And now let's try to scale it up. So instead of 0.5, we're going to put 2. Let's see what's going to happen. And the mesh is going to grow. Now they introduced somewhat new position behavior. And the difference will be, right now, we creating the mesh part and we applying the mesh at the start. But if we're going to apply the mesh and create the mesh after we edited the editable mesh, it's actually going to create the collision for that part. So let's see first how the position changes. If we still going to apply like the scale of 2, and we're going to press F8, and as you see, nothing changed, even though it's like the same script. We can as well try like to scale it down to 0.5, start. The same thing, we getting nothing in output, that means no error. And the thing with that, if we created mesh part at the start, we can change the position of the vertices as much as we want, and it's going to be visually seen, But if we're going to first edit the editable mesh and then apply, it's going to snap like the size of the mesh, the positions, right to the box that we have, like the bounding box. If we were to remove like the mesh ID, it's going to snap right to the box. And let me actually demonstrate it. So you see we multiplied by consistent scale. That means that mesh just getting smaller and then just getting scaled up. So that I'm even going to show that in Paint. Let's say that this is our mesh, like the circle. And then if we scaling it down, like in the center, and we creating the mesh part from it, what's going to happen, it's going to take that position and it's going to extend it to the bounding box we have. So even though we're going to scale it down, scale it up, it's still going to be fitted inside of the bounding box. Like, again, that mesh that we have. So now, instead of consistent scale, let's apply something else like mass.random. That means each vertex will be randomly offsetted, and let's look. You see? Now it's working. And it even has changed the collision. I don't know whether we can see the collision from here. Yeah, we're not able to see the collision, unfortunately. Probably we could just make some kind of raycaster that is just going to go through the whole mesh and like, look what's its collision. But for now, when we apply the random, you see it changes. And it's getting upscaled as well. So let's, for now, create mesh part at the start and apply the mesh part at the start. And then we're going to look into it once again. So now let's try something else, like for example, setting the alpha of each color to 0. Again, transparency 1 is transparent and alpha 1 is fully visible. That means alpha 0 should be transparent, but it works a little bit differently. It's not going to make our mesh transparent, but it's going to make the colors of the mesh transparent. Like, let's look, it has right now material of the plastic. And I'm going to comment out for now, that's code. We're starting, and that material stays. If we're going to set the alpha of each color, what is going to happen is that material is going to disappear, because the material alpha is going to be like 0 and it's going to be absolutely transparent. So let's try one thing, like material to marble, for example. And here it doesn't work as we expected. It works somewhat. It's hard to tell when it's going to change something and when it's not going to change something. Still no changes. On some materials, it's going to change. On some, it will not. And I believe if you're going to apply the texture to it, it's going to apply that alpha to the texture. So let's go through them. We can as well edit the normals of that mesh. Let's change the material back to plastic. So now the next piece of code is going to go through the whole mesh. We're going to go through the faces because the vertices and normals are not like bound together directly. So we have to get them through the faces. And how it's working, like each face has 3 vertices. Let's say that it's vertex 1, it's vertex 2, and it's vertex 3. That is our table for the face. And the face is still going to have like the normals for each vertex. So it's like 2 tables. And indexes are always corresponding to each other. Like this vertex has this normal, this vertex has this normal, and this vertex has this normal. So what we're doing, we're getting all vertices, we're getting all normals, and then we're going with the index. So we're getting the position of the vertex with index. So let's say our index is 1, we get in this vertex. Then we're taking the corresponding normal ID to that vertex. That means it's going to have the same index as this vertex. So we're just going to use I. And we're going to look at the position of the vertex inside of the editable mesh. If it's less than 0, we're going to apply like vectors 3 x-axis, otherwise minus vectors 3 x-axis. And let's see what kind of effect it does. And you see it already has some weird shading. That's kind of cool effect. And let's not use x, but use z instead. And let's look. Yeah, now the other part of the mesh is like white. And this part of the mesh is like dark, and it has even this weird transition. I don't know why, but it looks cool. Trying to mix like the light together, and because the normals like pointing in the different directions, they're not even having the time to transition. Therefore, we getting this very cool line. Wow, it's really like snow. Anyway, let's see what else we can do. with that. So we had two side light that we have in our x-axis or minus x-axis. And now let's take a look if we're going to make a circular light. We're doing literally the same thing, but instead of checking like the position, whether it's greater or less than 0, we're going to flat the position. That means we're going to dispose of y component and we're just going to take the unit of it. And we set in the normal. So let's look what is going to happen. Now it's beginning to be very, very weird in lighting. And if we rotate, see it changes as well, like depending on the sun. And if we're going to rotate the character like this, me not forgetting to anchor it, the light as well is going to behave very, very differently. Now let's continue. And now how we could skip the part where we're turning our mesh into the ball. I already prepared some code here and I'm gonna explain how it works. So we going through each vertex, we get in the position of it, and we taking a unit of its position. That means like, doesn't matter where the position is. Like, let's say this is the center, one vertex is here, one vertex is here, one vertex is here. If we're going to take unit, that means the magnitude of these positions will become 1. And it's already going to turn like in a circle shape, but with radius of 1. Here, we set in the radius to 5. That means we want the mesh to be 5 studs, right? And here, we apply as well the mesh scale. The reason for that the mesh size and the part size are very different. And if we're going to put this line, let's say to just 1, we want the radius of 5 studs. We have in our mesh, and it converted into a very, very small ball. The reason for that, just because the mesh and the part have different sizes. Let's even print them to see how different they are. We're going to print script parent mesh size and script parent size. Though, don't get confused with the mesh part here, because this mesh part, when we creating it, its size will automatically become a mesh size. So we could, of course, change it and the mesh size will stay intact, but the size that it's setting by default is like the mesh size. Therefore, if you're going to use a mesh part right here instead of script parent, you're not going to see the result. A small problem that I encountered during this video. Let's print them and let's see how different they are. First is 200, 240 and another is 882. Even though the vertices are like scaled down, our part is scaled down, the vertices have very big size. And you all the time dealing with that. Let's say you import in the mesh and it's going to be huge like this, right? And then you scale it down. You scaling down here only the size of this box where the mesh is. Let's remove the mesh. It's quite big. You're scaling down only the box, but you're not scaling the original mesh. The original mesh size is staying like that. So if we want to convert these positions like to real world positions, when we scale it down, we have to find the ratio by how much have we scaled it down. So we're taking the original size and we're dividing by size of the box that we have in. So let's see. We're going to start. And as well, our favorite ball. Very weird looking. Even showing the like probably encourages you to press on it, but who knows what he means with this flat face. Anyway, as you see, after we applied the ball transformation and we're going to tilt it, let's say, to the side like this, it's going to fall down and it's completely ignoring the new mesh. Like, it's going through the floor. But as we seen earlier, we applying the mesh part at the start, like before we even editing the mesh. But what if instead we're going to create the mesh part and apply afterwards, like after we edited the editable mesh, it's going to apply the physics to it, and the part is going to change its collision. So now, if we're going to create it, you see our character got turned into the ball and got squished to the size of the part, as I explained earlier. Now, if we're going to turn it, let's say, to the side, let's see what happens. You see it's already like rolling. And to check it even further, let's make the size like the same. And as you see now, it's perfectly rolling. Like it's still having its shape. To prove that this collision is real, let's say that we're not applying this mesh part and we are just going to set the size to it to 99. And if we're going to put it to the side, it just falls on the hand. But if we're using this mesh part, you already see the difference. Okay, let's look further what we can do with editable mesh. For now, we only changed like the colors, positions, and normals. But now, let's try adding and deleting the faces. So let's say we want to play somewhat like a Russian roulette, where the max random is bigger than 0.5, we're going to delete the face. So we're iterating through faces and we're rolling for each face. Now, if we're going to launch it, we're going to get an error, like editable mesh is fixed size, adding or removing elements is not allowed in experience. That error message might confuse you. I'm going to explain what it is. So what we are looking at is this property editable mesh fixed size. And it's telling that it's fixed size and we cannot add or remove. We can even take a look at the documentation of it. So fixed size that allow changing the values of the vertices and attributes, and it does not allow like to create or delete the triangles and even vertices. So this property tells, so if that property is true, we are able to change the values of the vertices like position, normals, and colors, let's say. But it does not allow us to delete the vertices or add the vertices with triangles. How we can fix it? You see, this property is read-only. But in another page of documentation, which I found accidentally, like without even looking at it, there's editable mesh options. And in description, it just tells that it's string and it can be anything. That will be as well very important for editable image tutorial, keep that in mind. So we are looking at the fixed size property that tells that we can just set it via options here. So we're going to take that name and we're going to tell that fixed size is going to be false. Now, as we printed, it was fixed size, so fixed size was true. Now we're just setting it to false. And now let's launch. And if we launch, you see, half of the triangles got deleted. And now we can even try and add the triangles, but we're going to do that on empty editable mesh.